Hello students, here in this class we'll discuss the concept of rest and motion, which is the most fundamental question as far as physics is concerned. So let's begin. So the first thing which we need to understand here is there is a branch of physics called mechanics. Now what is mechanics? Mechanics is a branch of physics that deals with the study of motion of objects. Motion can be simply treated as movement, right, in this context. So mechanics is the study of motion of object. Now mechanics further has been categorized into three parts. The first part is which we call statics. The second part is called as kinematics, and the third part is what you call as dynamics. Now mechanics is the study of motion. Now how you have distinguished these three branches, right, or what's the difference between these three? So statics is the study of body which is at rest. I'll describe later at what rest means, right? But you can treat it as stationary, right? So statics is the study of a body which is stationary. Kinematics, on the other hand, is the study of body which is in motion, but its cause is unknown. So its cause is unknown. Now what this statement means? This statement means I'm saying that there is an object. So this object is moving with some speed, right? I'm not telling you from where it got this speed. I'm just telling you that this object is moving with some particular speed, or this object is moving with some acceleration, or this particle has covered some displacement, right, or this particle has covered some distance. So I'm telling you basically that this particular object is having some motion parameters which we'll discuss later also, but I'm not telling you what is the reason for those motion parameters. On the other hand, if I'll talk about dynamics, it's again a study of motion, but the cause of motion is known. For example, let's say I'm considering an object and I'm applying a force, or you can say I'm pushing it, and because of this force it's moving. Now what's the difference between this case here and this case here is that here I know the cause, and in this case I don't know the cause. So I'll repeat the process again. There is a branch of physics which we call mechanics, which deals with the study of motion of objects. Now it can be further categorized into three parts. One is statics, the other one is kinematics, and the last one is dynamics. Statics is the study of body which is stationary. Kinematics is the study of motion without knowing cause, and dynamics is the study of motion with cause. Now let's proceed further. So first thing, let's describe what do we mean by motion, right? So let's understand this thing. If I'm saying something is in motion, this basically means that particular thing is in movement. Now what movement means? Movement basically means change in position. So you were at a certain position, now you have changed your position. That's the meaning of movement. But in order to understand motion, you can relate one thing here, that this movement is actually dependent on position. If your position is changing, you will say that the body is in motion, and if your position is not changing, then you will say that the body is not in motion. So let's try to understand now what is position. So if I'll have to define position, then let's say I have a room in here and there are two persons standing over here. I'll name them A and B. And let's say they are standing at a certain distance, let's say 1 meters. Now if I'll ask you that what is the position of B with respect to A, or I rather ask A, right? So if I'll ask A where B is, then the answer will be that with respect to A, B is at 1 meter. So the position of B with respect to A is at a distance 1 meter. Now let's say there's a person who is standing here outside the room, and let's call this person as C, and let's say this distance is 2 meters. Now I'll ask the same question to C. So I'll say, C, tell me where is B? Then C will have a different answer, right? So he will say that with respect to me, B is at 2 meters. Now here's the catch. I'm talking about the same person B, right? I'm talking about the same person B, but with respect to A, position of B is at a distance 1 meter, and with respect to C, position of B is at 2 meters. So what I can say is that as I changed my observer, my position got changed. So what you can conclude here is this, that with respect to a particular observer, the object can be at a certain position, and with respect to another observer, position can be something else. So now what I can say in a nutshell, that position is a relative term, which means that with respect to one observer, or you can say relative to one observer, the position can be something, and relative to another observer, the position can be something else. Now, once we have defined that position is a relative term and it depends on position, it depends on what observer you are considering. So what I can conclude now is that change in position, that is what you are saying, motion is also a relative term. And in order to make this more concrete, I'll take another example. Let's say there is a car. So there is a car over here, and there is a person sitting here, and there is a driver over here. So I'll call this driver as D and this person as P. And this car is moving down this road with some speed. Now I have a person or a traffic police. I'll call this traffic police as T, and the traffic police is standing at the signal. Now, if I'll ask P that whether D is moving or not, then P will say that with respect to me, D is not moving, and which is correct because distance between D and P is not changing. So P will say that D is not moving with respect to me. On the other hand, if I'll ask the traffic police that whether D is moving or not, then the traffic police will say that of course D is moving, right? Since the car is moving, Since the car is moving with respect to the traffic police and the driver is inside the car, so D is also moving. Now again in this example, when my observer is P, D is not moving, and when my observer is T, D is moving. So I'm talking about the same object, or you can say same person D, but with respect to P it's not moving, and with respect to T it's moving. So again I can conclude that motion is a relative term. Now, having understood this, what we can now ask is a question like this. Is there anything which is at rest? Then you can ask two questions. One question is relative to what? So it needs a clarification, right? Relative to what you are saying that the object is at rest or not. And if you are not defining your reference, then you will give the answer no. Nothing is at absolute rest. Or in other words, you can say everything is in motion with respect to something. Now you can have a contradiction. The contradiction could be that I am a person on earth, there is another person on earth, we are not moving with respect to each other, so we are at rest with respect to earth. But if let's say we have some technology or something and there is a person on moon who is observing you two, then what the person on moon say? Hey, you are moving with respect to me, right? So they were at rest with respect to earth, but when I asked a person on moon, then the person said, no, you are not at rest, that's an illusion, right? You are in motion with respect to me. Similarly, a person on moon will be in motion with respect to something else. So if you'll go on expanding this idea, you'll get to know that nothing is at absolute rest and everything is in motion with respect to something. So this is a broader idea which you need to keep in mind. Motion is a relative term, rest is also a relative term. There is nothing like absolute rest. Now, the next concept which I would like to describe here is what is the concept of point mass or point object. So now we'll discuss what the concept of a point object is. We quite often see in physics that this point comes into picture again now and then, right? What is the meaning of this point object or point mass? So let me take up an example. Let's say there's a train. So there is a train here, right? It has to cover a long path and it has to reach from Kanpur to, let's say, Bangalore. And for simplicity, let's say I have considered the distance between them as 3000 kilometers. So I'll have to go from Kanpur to Bangalore and roughly I have taken the distance to be 3000 kilometers. Now this train is having a length of, let's say, 20 meters, right? So this train is having a length of 20 meters. Now if I'll ask you, if this train moves with 100 kilometers per hour, then in how much time this train will be able to reach from Kanpur to Bangalore? So since in 1 hour it covers 100 kilometers, so in order to cover 3000 kilometers, it will take 30 hours. So in order to cover 3000 kilometers, it will take 30 hours. Simple unitary method, right? 100 kilometers in 1 hour, so 3000 kilometers in 30 hours. Cool. Now, if let's say the same train, right? The same train is moving and there's a pole here, and length of the pole is, let's say, 1 meters, right? Now if the train moves like this, correct, if the train moves like this, same train, 100 kilometer per hour, right? Now if I'll ask you that in how much duration the train will be able to cross the pole, then you will say that in 1 hour it covers 100 kilometers. So in order to cover 1 kilometers, it will take 1 by 100 hours. And since 1 kilometer is 1000 meters, so I can say in order to cover 1000 meters, it will take 1 by 100 hours. Or you can say in order to cover 1 meter, it will take 1 by 100, 1 divided by, just a minute, so I'll write it here. In order to cover 1 meter, it will take 1 divided by 2 zeros already there, 3 zeros will more come, so you'll have 5 zeros and then hours. Now the question is the answer correct? The answer to this thing is no. Why the answer is not correct? Because here when the distance was 3000 kilometers, length of the train was insignificant. When the distance was 3000 kilometers, length of the train was insignificant. So you considered whole of the train as just a single entity, and how much time this single entity will take in order to cover 3000 kilometers, that is what you found out. But here if you will take it as an entity, then what you will get to know is that even if train covers 1 meter in this much time, the train has still not crossed the pole. So you cannot say that in this much time train has crossed the pole. So the point which I am trying to make here is that in certain situations, length of the object becomes insignificant as compared to other numbers, right? So insignificant as compared to other numbers, like 3000 is a large number, 20 is a pretty small number as compared to 3000, so you can ignore it and you can consider train as a point and you can apply the formula directly. But here this 1 meter and this 20 meter, they are not negligible with respect to each other, so you can neither consider one as a point mass or the train as a point mass or object, right? I hope I made this point clear. When the distance of observation is huge as compared to the dimension of the object, you can treat it as a point object. When distance of observation is not that big as compared to dimensions of the object, then you cannot consider it as point object. I'll take up another example. If let's say you have a tiny ball over here and you have a rod over here. Now if you'll drop both of them, what will happen? This small ball will fall straight away and will reach the ground. But if you'll drop this rod, Let's take up this example. Let's say you have a tiny ball over here. If you'll drop this ball, what you'll observe that it'll go straight, right? And it'll reach here. On the other hand, if you'll take a rod over here and drop it, what happens is that this rod, while going down, it will tend to rotate. So that means when you're considering point objects which are pretty small, you are getting certain kind of motion. And when you are considering objects which are not point objects, not point, then you are getting a different kind of motion. That's why distinction between point and not point objects is crucial, because a point object can show certain kind of motion which the non-point object will not. It can show a different kind of motion. So in a nutshell, about point mass, what I can say is that it depends on dimension of object with respect to observable distance. If it's negligible, then you can consider it as a point. If it's not negligible, you cannot consider it as a point. And point objects show certain kind of motion, non-point objects show different kind of motion. Another example of point object could be, if I'll see a ball from a near space, right? Let's say that you are just standing adjacent to a ball, a football, you'll be able to realize that, okay, the dimension is big. But as you start moving away, this ball will seem smaller and smaller, right? So as your distance of observation increases, the perception of the object, which was earlier the dimension was significant, now if you'll see it from, let's say, 1 kilometer, the dimension will seem insignificant, right? So point object is what concept? It depends what the observable distance is or to what you are comparing, right? So point object is a matter of comparison. The last example which I'll explain you is this, that if you'll compare a human with an ant, then of course ant can be considered as a point, because you're comparing two numbers where one number is a lot bigger than the other one. But if you'll compare an ant with another ant, then it's not a point. So point object is a matter of comparison. It's a matter of what other numbers you have. And why is it important? Because point objects show certain kind of motion and extended objects will show some different kind of motion.